Hi gang. Just gonna look at some basics of probability, which is what you're due today to do today and tomorrow's lesson. So just to make sure you're happy with that. First, some keywords: event and outcome. Not to be confused. The event is what you are doing that you are trying to make predictions about. So, for example, rolling a dice. That's the event. The event is the rolling of the dice, or the event is picking the card, or spinning the spinner thing. The outcome is what we are looking about. For example, what's the probability of rolling a 6 on a dice? The outcome that we care about is the 6. Okay, the event is rolling the dice. The outcome is the 6. Or on a spinner, if you're talking about the probability of spinning more than 2 or something, whichever numbers are on the spinner, 3, 4, 5, for example, are the outcomes that you care about. Equally likely outcomes and fair are similar here, because to begin with, what we're talking about is events with equally likely outcomes. For example, a dice, it is equally likely that it'll land on a 1 or a 2 or a 3, etc. They're equally likely, okay? And that's what we would call fair. If a spinner spinner has 5 equal parts, we would expect, if it's fair, for there to be an equal probability of landing on each part, and that would be fair. And lots of the questions ask for your answer in simplest form, which is a shame, because I try and encourage you not to simplify probability. There are lots of reasons when we're talking about and events. So two events, the probability of two events, I beg your pardon, two outcomes happening, well, two events and two outcomes, then we want the denominator to be the same, blah, blah, blah. But anyway, so you do have to simplify, but we've done that in recent weeks during lockdown, so you should be happy with that. Okay, so the first quiz is just about putting probability into numbers, giving values to probability. So you're all familiar with a number line. Whoops. And this being impossible. I want to sing, what's his name? And certain. And then you got 50-50 in the middle. And other ones, unlikely, likely, very likely, etc. You won't really be using those anymore, I'll be honest. We think of it as likely and unlikely, but whenever you're asked for a probability, you're going to need to give a value. So probability is all between 0 and 1, or indeed 0 and 100%, which is the same. You could even think of that as 1 over 1, but I'm not sure why you would. But that is the domain of all probability. You cannot get greater than 1, you cannot get less than 0. So it will all be about fractions and decimals, or indeed percentages. And we tend to use fractions. Certainly I prefer fractions, but fractions and decimals more than we do percentages. But whatever, they're all the same. Good, okay, so what the examples it's given, it gives you the line from 0 to 1, and then it splits it up, and then says, right, what is the probability of here, sort of thing. And I just wanted to run back over, because I'm sure you know how to do that. We need to know how many equal parts it is broken into, and then how many along we've gone, how many we care about, sort of thing. But I just want to remind you, we start here and we go 1. So we're not going 1, 2, 3. Just don't be confused. I try not to be confused by that. We are counting these bits. So until we've done the length of 1, we haven't covered 1, we've covered less. So 1, 2, 3, 4, 5. Good, so it's out of 5, lovely jubbly. And then we've gone 1 along here. I'm sure you're aware if the star was here, it'd be 2, 3, 4, and then 5 out of 5 is 1, so that would be certain. Okay, so there's quite a few like that. I'm guessing I hadn't seen them, but because it's asking for simplified, that might be on the next one. But of course, I'm sure you know. Let's remove that star and do somewhere else. But if I split those in half, then we should have 10. So it'll be out of 10. And if I go somewhere like here, so let's just check there's 10 starters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. 1, 2, 3, 4, 5, 6. And that's gone 6 along. So what you're looking for is a common factor. What number goes into 6 that also goes into 10, other than 1? Because if we divide by 1, it doesn't really help. So we can, 6/10 is the same as, if we divide the numerator and denominator by 2, 3/5 The reason being, I want to remind you, we've covered this before, but just to remind you, what we're saying is, well, 6 is the same as 2 times 3, and 10 is the same as 2 times 5. And we can write that into separate fractions. 2 halves times 3/5, and then 2 divided by 2, anything divided by itself is just 1. So when we've got 1 times 3/5, we'll just call it 3/5. So that's why. But that's the first task, no problemo. And then the second task is about the probability. Now, of course, some of you, lots of you probably, most of you won't know what a pack of cards looks like. It's much easier for you to look on the video. It gives an outline of all the playing cards, the suits and everything else. There's basically 4 what we call suits, which are diamonds, hearts, spades and clubs. And they go, well, you'll have to have a look, because that is confusing. There's only, I think, 2 questions on playing cards, otherwise I probably wouldn't have set it, because I know you won't be familiar. But the key bit with probability for our equally likely outcomes, so probability of the outcome, so probability of rolling a 6, or probability of flipping a tail, or whatever you're looking at. The probability is, so this is what we care about, the total possible outcomes. So first of all, the denominator, because I think usually it's better to think of the denominator first. The denominator, total possible outcomes on a dice, that would be 6. On a coin, that would be 2. On a spinner that has 5 equal parts, would be out of 5. So that's always going to go on the bottom. If you've got 20 beads in a bag, then 20 would go in the bottom. And then the number of ways it can happen. If you want the probability of rolling a 2 on a dice, well, there's only 1 2 out of 6. There's only one of those, so it would be 1 out of 6. If you wanted, some of the questions on the dice are things like, if you wanted perhaps a factor of 6. So the factors of 6. What we like to do is this. Depends whether you call it an insect or what you call it. 1 times 6 is 6. Good. 2 times 3 is 6. I would go to 3, but 3 is already covered, so they are all the factors. There are 4 factors of 6. So we've got 1, 2, 3, 4. They all appear on the dice. So the probability of a factor of 6 equals, well, it's out of 6, isn't it? Because there's 6 different sides and they're all different. And 1, 2, 3, 4. 4 out of 6. And if, well, it does ask to simplify. Is this the same one we did? No. There you go. 2/3. Good. And that's basically the basics of probability. We will get onto where they're not equally likely outcomes and all the rest of it. But as long as you've got a really good grounding in the basics, I think you'll find the rest quite straightforward. Maybe not straightforward, but because it's kind of real life and it's kind of often logical, you'll be all right. But that will tell you how to do both today's and tomorrow's task. No sweat, I reckon. Looking for 100%, please, peeps. Bye-bye.